Hi guys, welcome to Learning Electronics Repair. If you watch my recent video with the Athlon retro motherboards, you'll know that my power supply packed up at some point during the making of the video, and that's this one. So this is an old ATX power supply. It has the 20-pin connector on it, and the important thing about these is the fact that they have a very high current rating on the 5 volts. So a lot of the processors, these Athlon Thunderbirds, which I had, that were on motherboards that don't have the extra 12 volt connector, are drawing a very high power from the 5 volts. And a modern power supply will not run those retro motherboards and processors. So this was working, and then I actually got the motherboard to boot into the BIOS. I attached the hard drive, which is also powered from the 5 volts on here and 12 volts. And after that, the motherboard kept hanging on boot. It was stuck in some sort of loop. I then tried another known good motherboard of the same type, basically different model, same type. And that also wouldn't work on this power supply. I then took my other known good 20-pin ATX. That's this one. Okay, again, 20-pin. This is an FSB power supply, so we can look at the ratings on this one. And it is actually much lower. And yet the motherboard would boot from this, both the known good one and the one I was trying to repair. So whatever happened, something happened with this power supply. After I published that video, somebody asked me about this board. So this is my known good one. Again, there's no 12 volt connector on this. It runs directly from the 5 volts on here. Yes, there is 12 volts here as well, but the 5 volts is powering the VRM as far as I know. And somebody wanted to know what processor was on this one as well. So we can actually have a look at that right now. I did say at the time I didn't actually know, so apart from knowing it was something similar, and this one is a 1333, whereas the other one was a 1300. So that's the processor which is on this board, okay? Another comment I will just answer as well. So these boards, somebody commented that they were worth about £35 on the retro scene, and I said I thought they were worth a lot more. And the reason being that these motherboards, both of them have an ISA slot, okay? So you have AGP, PCI, ISA, and that is what makes the difference. Most motherboards with this type of processor do not have the ISA slot, because ISA was pretty much outdated by then. These were probably the last of the boards to have ISA on, and that's why they are very sought after on the retro scene. Okay, so let's see if we can find anything wrong with this. Okay. Okay. Well, the first thing we can say is it's full of dust. Yeah. Let's see if we can clean it out. Okay, and now we've removed the dust. The second thing we can say is we have some visibly bad capacitors, and that's what I thought the problem would be. So let's just see if we can move some of these wires out of the way. Okay, well, I can see straight away that this fan on the top cover is hardwired. That one which goes to the front actually unplugs. Okay. But there again, we have this big choke which goes onto the main board as well, and these two wires. So to get at this, we're going to have to unscrew the screws that hold the board in and unsolder at least a couple of wires, unless maybe they're plugged in over here actually. Let's see. Try this handy tool I have. Oh yeah, that gets in there easily. I like that. Okay. Well, that's now loose. I'm going to just get rid of a bit more dust here and unplug these two connectors. It looks like one of them goes to the power switch on the front and the other one goes to the choke, which then really just leaves the ones going to the fan, which are actually attached to this board. So let's see, can we get this out now? Yeah, maybe. We extract this lot. I think I just cut this little cable tie, probably make it easier. Yeah, there we go. So a bit tight, but I think this will actually come out. Yeah, it did. And then this one. Yep, it did. So what's holding this on now? Well, we appear to have some more wires going down the front towards the fan. Okay, and the one's going to this one. I think I'll actually unscrew this fan, that might help. Let's use the screwdriver again. So, see if it'll do this. It's proving very handy. Switch the light on, try again. Okay, so that's out of the way. Now what do we have? The thin wires go to this little plug and they disappear somewhere under the fan. Maybe something to do with speed control. I think if we just take off another cable tie, we can sort this lot out. So that just comes under here somewhere. In fact, no, it's not even cable tied, it's just twisted around basically. There we go. Yeah, goes under this one. Well, that's actually the plastic clip, which just stops the wires being cut by the sharp edge of the metal. This is the cable tie. And that's now free, that's good, so that's off. Can we now check this out? I think we probably will be able to. Just a little bit more effort, it's just still stuck. It's out. Okay, so let's have a look to see what we have. Well, it's quite obvious. We have 1, 2, 3, 4, 5, 6 bad capacitors here. The small ones all in much better condition. We can see the tops of these have bulged quite badly. So that just goes to show really how well these things will often work with bad capacitors. It's only until a couple of days ago it just stopped working. Okay, I've used it for several months, never opened it up because it was working when I got it from a computer at the car boot sale. I'm going to draw a little diagram of this, just the position of the capacitors and the polarity, although it looks like, yeah, all the negative ends are on the black part on the silk screen, so we know which way they go. There may be a few different values here, it's just so I know which effectively one came from where. So this is just a basic diagram. I'll show you in a moment. Okay, you see them there. You see them there. It's just the layout, so I know which one goes where. Now let's remove them and see what they test like. As I unsolder each one, I'll make a note of the value on that little diagram I just made. These are really easy to do, to be quite honest. Don't need any flux or anything. Maybe when you're cleaning the holes out, but you can literally do it this way. So hit up one end, tilt it one way, hit up the other end, tilt it back to the first end, tilt it a bit more, and out it comes. Yeah. So that one we have is a 1010 volt. I can see this one is also 1010. So literally just making a note as they come out. Exactly same technique then. Heat tilt. Heat tilt. That just fell out. I normally clean the holes as I'm going along so I can see where I've taken capacitors from easily from this side. It's one of them. This is where braid does work very well once you remove the component. So take the thing out first, then just clean the holes. Okay. Next ones. One is here somewhere. I think it's actually here. Yeah, it's moving. If you can't get it to just desolder, just put a little bit of fresh solder on. I'm not sure if it's actually here or the other side. I think it might be here. Yeah. Okay. This is a 1016 volt. So probably the 16 volt ones are on the 12 volt rail and the 10 volt ones are on the 5 volt rail. That makes sense. Why they didn't just use 16 volt for all of them, I really don't know. It would work just as well. Maybe cost. Maybe the 10 volt ones were slightly cheaper. Next one is here somewhere. I think it's probably here. Let's have a look. Yeah, I think that moved. That's one end of it. Yep, fell out. Yep, that's where it came from. Okay. Probably the same. Oh, I say probably the same. It's different. 2200 10 volt. Almost made a mistake there on my diagram, but I spotted it. Okay. Two more. This one's somewhere a bit nearer to this end, probably here. See? Yeah, you probably saw the leg went into the board there. Push, pull, push. Yeah, it fell out. Same, 2200 10 volt. And we have one more here. I think it's these two pins. Okay. Out it fell, and that was 1016. Let's have a look to see how they read on the capacitance and the ESR meter. Okay, so first the pair of 1010 volts. Well, the capacitance is very low, 190. Other one, very similar. Okay. How about the ESR? Well, it actually reads quite well. I'll just go down to a lower range. So that's the 10 ohm range. No, that's bad. That's bad, 2 ohms. Let's just see if this is zeroed. Not quite, let's zero it. Okay, go again. Yeah, 2 ohms, that's no good. Other one. Similar, a little bit better, but it's no good. So, capacitance was very low, ESR was a bit high, I've seen much worse, but it wasn't good. Here are the 1016s, let's try these. Well, ESR is about the same as the other. And we'll measure the capacitance afterwards. Yeah, they're all in the same range of badness, really. Capacitance. So this one, yeah, 100 and something out of 1,000. This one, 100 and something out of 1,000. You even start to wonder if the meter's working properly. Well, here's a 1500, let's see. Oh, 1500. And how about these last ones? So these are the 2200s, okay. I'll leave it on the 2000 range. If they read very low, it'll read 60. Okay. $79. What's this say? Similar amount of badness on this one. Likewise. So what is remarkable is that this thing was even working at all until today. Well, in fact, if you saw the last video and the first half of the video, it was working. The motherboard would boot into the BIOS. After I attached the hard drive, it wouldn't. Okay? And once I deattach the hard drive, it still wouldn't. So let's change the capacitors. Well, the weekend has gone by and it's time to continue with this repair. I'll just mention, by the way, I've been really busy this weekend, so I've been upgrading the camera system again. The main thing now is I have an autofocus camera above the bench rather than the manual focus one. So if I turn something upside down, give it a second or so, it will refocus. And I think that'll help a lot in the videos, to be quite honest. This was the problem I was having when I was like trying to put things at an angle. It would be out of focus, but now give it a second or so and it sorts itself out. So let's see how that goes. Yeah. The other thing I just mentioned, I have more zoom on now. So effectively, this is the maximum zoom and this is the minimum zoom. Okay. So let's see how it goes. But mainly back to this repair. So we have 6 bad capacitors. They were a mixture, and here we are, autofocus, nice. So we have 4 of them at 1000 microfarad, 2 at 16 volt, 2 at 10 volt, and we have a couple of 2200s at 10 volt. Okay, I have 16 volt ones in stock. I don't stock the 10 volt ones generally, so I'm going to replace all the 10 volt and all the 16 volts with 16 volts. Okay, that's fine, guys. You can put a higher voltage like that in. It's not really a problem at all with electrolytics. So if you don't have the exact ones, just do something like that. Yeah. Okay, so let's solder these in. Just before, let's just check a few of them, just see what the ESR reads on these good ones. We saw with the bad ones, the ESR was around 2 ohms, a little bit less. And that is not good. 2 ohms is not a low ESR. So we just take one of these 1000s. These are new ones. And you can see 0.06, 0.055. So there's a huge difference in the quality of these capacitors compared with the faulty ones. Okay. 0.012, that's on the 2200. Generally speaking, the higher the capacitance, the lower the ESR. That's another 2200. And 0.004, very low. And we go to another one of the 1000s. Oh, very low again, actually. So there isn't a lot of difference, but these are all good compared to the ones we took out. Okay. We may as well check the last one. There. Okay. There we are, guys. New capacitors fitted. Okay. Nicely cleaned up on the other side. So let's just put this back together and see if it now works correctly. Guys, I've put it all back together. I've connected the current limiter. The light bulb is just there. A little bit hard to get the camera towards it, but still. So when you've worked on something like this, it makes sense to at least put the current limiter on it first to make sure you haven't done something very bad and something's going to go bang, yeah? I'll also attach my ATX analyzer as well, and we'll probably see this power up with a bit of luck. That's this thing. So this power supply doesn't have active PFC, it has passive PFC. This does fit in here, by the way. It's only go one way, you can't get it wrong. Okay, so let's see what this wants to do. Okay, I'll try to put that way you can at least see it. We'll power on and what happens? Well, it starts, it's running. So I'll switch off the current limiter now, it's just directly on the mains, and we can have a look. It's bleeping because I don't have the 4-way 12 volt connected, and that's why it's bleeping, but that is working. So let's connect the motherboard that this wouldn't work with and see if it now works. This was previously stuck in a boot loop then, yeah, we can see on the card there. So let's see what it does now. Just power it up. Start. Well, it's not in the boot loop anymore, that's for sure, okay? And we have a picture. So this power supply is now working. And I think that tells us a few interesting things, or it should do. Okay, so when you're using something like a bench power supply that is your known good one, yeah, for the old retro boards, don't do what I did, which is I just found one at the car boot sale. It was just working, so I just assumed everything was okay, and everything wasn't okay, as we eventually found out, yeah. So if I'd taken the effort to open it up and have a look before I declared it my new known good one, better than my previous known good one, we wouldn't have had this saga, yeah. So that's the lesson to take away from this, really, guys. Just keep an eye on your test equipment and on things like this. It's not test equipment, but it is a necessary part of the job, and you need to make sure these things are good. Okay, hope you enjoyed that one. At least we got to the bottom of the problem, and I will see you all soon on another Weird Electronics Repair video. Ciao for now, guys.